a globe problem. So thanks, Walter, here, but I don't know why it doesn't have a little personal dome. How do I turn this on? I don't remember. But, all right. Now, as we go through the day, we're going to see, let me change the direction. All right, so this will be us seeing the sunset. All right, watch. Now, as it goes throughout the day, so the sun is actually up here, right? This is the actual position of the sun, but everyone has a limit to their view. You have 360-degree field of view. If you look all the way around, you have 360 degrees. So not technically a field of view at any one point, but you have a horizon around you, 360 degrees, and you have a limit to how far you can see. You can't resolve things forever. Absolutely insane that people think they can. So as it gets close enough, it enters your azimuthal grid of vision, right? Azimuthal grid is simple, right? You have the observer position in the middle. You have your zenith position, which is directly above you. Then you have your azimuth, which is you looking out around the horizon to get a direction. So now you basically have an L that's perpendicular, and you take angle measurements between that. And this is, if you do this all around you, it's going to give you this right here, an azimuthal grid. Now this is how we see, because we are actually looking at the sky to get those measurements in the first place. Okay, now, as the sun gets close enough, it pops into this limited hemisphere of vision, and it starts to rise. And then it's going to keep going. Now you see the actual position is up there, but we're just seeing it within our limited field of view. And then it keeps going down, and then it sets. It doesn't change angular size, because if you look at this line inside of here, it's at the same point. It's at the same point within that dome the whole time. So it's not expected to change angular size, because it's only picked up and perceived within that hemisphere of vision. So it actually wouldn't change angular size. Now on a globe, it has to change angular size. Let's see if they'll show us a video. Okay, so this is what's actually happening, right? This is terrible, but it's not a good depiction of yours. So I've explained it a couple times, but obviously if you have a globe, right, then the sun is going to be closer to you at the top of that curve. You have a curve. If you're at the top of it, you're going to be closer to the sun than when you go down further away. So the globe predicts that the sun will change angular size throughout the day, right? It'll be small, get bigger, and then back to getting smaller at a very specific rate based on geometry. Where's the measurement for that? It doesn't exist. People claim, oh, it's too small to measure. That's incorrect. Provably, we have optics that can measure it. Why has it never been measured and verified? If it doesn't change at that very specific rate, the globe is debunked irrefutably based on geometry. Never been observed. Just hilarious that the angular size change argument actually debunks and refutes the globe, yet makes perfect sense on a flat Earth because it's just entering your hemispheric limit of vision. So you're not expected to see it change angular size until you get throughout the year. Now, as you see here, now it's further away. So this is where you will change angular size throughout the year, because now the sun's actual position, if you mount some, is further away throughout the year. There you go. Now they just looked at the sun, right, and then they claim that actually the Earth is moving on that path.